Hello everyone. Here I'm going to introduce an interesting system. Predict the suspicious advertisement activity on social network platform Zhihu. I'm Hetong Li from Computer Information Science Department in the University of Florida. So why I choose to implement this system? The number of marketing communities with malicious intentions on social network platforms grows rapidly these years. They utilize the network's tremendous influences to increase their brand awareness. So I choose one of the famous social network platforms, Zhihu, since it develops rapidly this year. With the development, it also becomes a potential carrier for the viral marketing. It also becomes a potential carrier for viral marketing based on the huge number of users it has and the mechanism it works. Once the viral marketing behavior blends with normal users' behavior, it's hard for users to detect it. So I decided to implement a detecting system to evaluate the possibility of a community that is being a marketing community. Here you may concern how the marketing community works on Zhihu. There are mainly two ways. The first one is to answer the questions asked by their member. They will see the advantage of their product. When other people focuses on the question, all the answers are about the advantages of the product. The second one is to praise the answers which give positive opinion about their product. Since a user could praise or oppose others' answers, so the marketing team may praise a positive answer and push it to the top answer under a question. So there are mainly four steps in the system. The first one is to collect users' information. And based on this information, I divided the users into different communities. Then I designed the evaluation criteria for each communities to decide the threshold to detect the suspicious community. Then the last one, the threshold for marketing community. The related work here is the community detection algorithm, the fast unholding community detection algorithm. There are mainly two steps in this algorithm. The first one is modularity optimization. As we can see here, each node in the network is divided into the community which its neighbor belongs to increase the modularity. Then the second step is community aggregation. Each community divided by the first step will be regarded as a single node and will be merged with its neighbor nodes to form a new community. So if the modularity of the new network increases, the next aggregation will start. Otherwise, modify will be abandoned. When the modularity stops increasing, the final result of community detection is established. The modularity could be calculated through this formula here. Based on that, let's look at the system design. The first step is the data scraping. I scraped top 500 users' data from Zhihu using Python. So why I choose the top 500 users as a dataset? Because their activities have more influence than the ordinary users with a small number of followers. So this top 500 users number of followers are large. I collected the followers, the following relationship, the following topic, and the answers, as well as the praises the users gave in the past 6 months. Then is the community detection part. This part is based on the information collected on the data scraping part. Before I introduce the community detection part, I'd like to mention that there are 2 confirmed marketing communities were detected several months ago. Observed that the following relationship of most users in the 2 communities and the market communities on other platforms are mutual. So I designed a filter to delete the one-way relationship between users before apply the community detection algorithm. For demonstrating, let's look at the picture here. There are 3 users in the community A, B, and C. The left picture here is the original following relationship graph. There's a one-way relationship from A to C and a two-way relationship between B and C. After the filtering, I deleted the one-way relationship here and maintained the relationship between B and C and changed it to an undirected edge. Then based on this graph, this graph represents a relationship after the filtering, and which is based of the community detection algorithm. I use the graph in Python to divide the users into different communities according to their filtered following relationship here, like this. Then is the most important part of the project is the evaluation factors design. The first evaluation factor is the community participate rate, CPR. The CPR values equals to the PIJ values divided by the ISI values. I equals to the identity of detected communities, and J is the identity of question. PIJ here represents the number of users who answer the question J in community I, and ISI is the number of users in community I. By calculating the value of CPR, the system could statistic the percentage of users in one community who answer the question J. If the value of CPR for a specific question in one community is extremely higher than others, the community for this question is suspicious. And the second criteria is the answer community rate, ACR. It equals to the CIJ divided by AJ. I and J in this formula is the same as the first formula here. And the CIJ represents the number of answers under question J, which are given by community I. And AJ is the total number of answers under question J. Through calculating this attribute, the system could figure out the overall performance of the distributing relationship between question and its answers. If the value of ACR is extremely higher for a community under a question, the community may deliberately intervene the tendency of the answers under this question. And the third one is the question correlation rate QCR here. It equals to the sum of Q and J divided by MI. I equals to the identity of detected community, and U is the size of the community I. J represents the identity of question, and Q and J is the number of presets given by user U and MI. And MI is the maximum number of presets a community could give for one question. So why I designed this criteria? Through the first and second evaluation criteria, the system compute the ratio of users' answer rate for questions, but they didn't contain users who gave their option.